Here is a vector application problem involving flight and wind speed. The question is, a pilot wishes to fly on a bearing of 22 degrees north of west with the ground speed of 300 kilometers per hour. There is a 60 kilometer per hour wind from the direction 15 degrees west of south. Calculate the heading and the airspeed that the navigator should use. Now, to solve such problems, the first step is to draw the vector diagram, right? Here's one which I've already sketched for you. Let me explain you how we get this diagram. Now, so first you make your axis, this pointing towards the north, and then read the problem once again. It says, pilot wishes to fly on a bearing of 22 degrees north of west with the ground speed of 300 kilometers per hour. So that is the ultimate position where the plane has to land, right? Or the course which a plane need to take, right? So that is from west 22 degrees north. So this is your west. So from west, if you go 22 degrees north towards this, so that is 22 degrees. Then that is the line which is the required flight line. And the speed is 300 kilometers per hour. So 300 on this vector denotes the speed, and from west 22 degrees north gives the direction. So that this line indicates the final, I should say, V plane, right? Now if this is 22 degrees, then from north it will be 90 minus 22 degrees, right? So I'm just showing how to do all these calculations, and we get 68 degrees there. Correct? So that's the first thing. The second is, there is a 60 kilometer per hour wind from the direction 15 degrees west of south. So this is the wind direction. So always place wind towards the origin, right? And then we can translate it to the required point. So it is from south 15 degrees west. You see, this is south and this is 15 degrees west from south, correct? So that gives you this angle as 90 minus 15, correct? So we have 90 minus 15 here, this angle. So which will be 75 degrees. So this angle is 75 degrees for us. Calculate the heading and airspeed that the navigator should use. So of course, since wind is pushing in this direction, the plane has to go in a heading which is less than 22 degrees. And let's assume theta less than 22 degrees, right? So this angle is lesser than 22 degrees. So plane will be actually directed, so nose of the plane will be in this direction. But actually because of the wind, it will be pushed and it will go at the required course. So that is how we make our vector diagram. So that is, we will say velocity of the plane, initial velocity. So first, initially it starts in this direction, right? The nose is in this direction. And because of the wind, actually it reaches here. Correct? So to get this vector here, we translate the wind to the tip of our velocity of the plane. So that is how we make a triangle. Right? Now the idea is to calculate the angles. So in this triangle, we know that this side is 300 and the wind is 60. So we also know this is 60. So we know these two sides. We need to know this angle, which can be calculated. Correct? So how much is this angle? So basically extend this. Do you see these two lines? So we are trying to find this angle. So this line we are extending down, right? And the wind. So that is the wind, which here it is 15, and we want to know what this angle is, right? So this angle is same as the angle at that tip, correct? Where both the heads meet, correct? So how much is this angle and how will you calculate that angle? This is a question. So here is the calculation shown for you. When this is 22, then this angle is 68, as you can see. From north, the final direction is 68 degrees west of north, and that is a vertically opposite angle. So the one shown to you is also 68 from here to here, correct? So we have this line coming like this and this line, so this is 68. So what we have here is, this is 68 for us and this small angle is 15, right? So the total is 68 degrees plus 15 degrees, and that is 83 degrees. I hope you understand that part, correct? So we get 83 degrees here, correct? Now we have a triangle in which we know two sides and the angle in between. Okay. Let me show this calculation once again. So what I will do, I will draw this part enlarged for you and then redo these calculations so that you understand. So what we have here is, so we have this, so this is this line, correct? We're calling it VP. And here we have wind. Let's say V wind, right? And we know that the angle which it makes from here is 22 degrees, correct? And the angle which wind makes is 15 degrees, correct? And therefore this angle will be 90 minus 22, which is 68 degrees, right? So this is vertically opposite angle, 68 degrees, correct? So when you add 15 and 68, you get that. Now let me translate this wind here. So this angle is same as total of these two, which is 15 plus 68, 83 degrees. So that is how we get our angle, correct? I hope now that is absolutely clear. So we have this diagram here in which we know two sides, 60 and 300, and the included angle is 83 degrees. And now when we know this, then we can use the cosine law to find the other side, which I have written as x, correct? So x is equal to magnitude square root of square of these two, right? So it is 60 and 300 square minus 2 times 60 times 300 times cos of angle in between, which is 83 degrees. And now we can use a calculator, correct? And then multiply and get our result. So we get square root of, within bracket, 60 square plus 300 square minus 2 times 60 times 300 times cos of 83 degrees, bracket close, equal to, and we get 298.7. we can write it as approximately 298.7. So that becomes this velocity. So the plane heads with a velocity of 298.7. So we got that much, right? Now, so we know the magnitude of velocity. What else we need to know? The angle theta, so that we can define that it is so many degrees west of north, right? Or so many degrees north of west, either way. Now when we know this side, so we know all the three sides, we know one of the angles, we can use sine law to find theta, right? So sine theta over the side opposite to this, theta angle is 60 equals to sine of 83 over, we just calculated this velocity, which is opposite to 83, 298.7, correct? Now from here we can find what theta is. So theta is equals to sine inverse of, so I'll write it in different thing, 60 times sine of 83, okay, 60 over 298.7 times sine of 83 degrees, correct? And then we can use calculator to calculate this value. So we have second function, sine of, within bracket, so we do 60 sine of 83 divided by 298.7, bracket close, and we get our result 11.5. So this angle theta is calculated as 11.5. So this is 11.5, right? And now we can say what is the final direction. So we can, the direction is 22, it was 22 from here, so we can take away 11.5 and then write 22 minus 11.5 is in this way. So from west, that much angle towards north, or you can write this as 68 plus 11.5, giving the direction from north towards west, or you can also give a bearing angle like this and add 270 to this angle, correct? So that is how you can write down your answer. So there are a couple of ways to write this answer, right? So what I will do is, I'll give it from north, and I say, well, this is 68, so the total angle from here to here is 68 plus 11.5, so we have 79.5 degrees from north, right? So I can write this direction as from north, 79.5 towards west. So that becomes the direction in which the plane should be heading. So that is our answer, right? So the heading and the airspeed of the navigator should be velocity of 298.7 kilometers per hour, and the direction is 79.5 degrees west of north, correct? So that is how we are going to do this question. I hope you understand and appreciate. Thanks and all the best.